You know, in the world of technology, some of the most powerful ideas are the ones you've never even heard of. Today, we're going to pull back the curtain on a true ghost in the machine of modern computing, a revolutionary operating system called Multics. Let me ask you something to kick things off. What if the fundamental security protecting your phone, your laptop, your data right now was first dreamed up over 60 years ago? Sounds kind of crazy, right? Well, it's a lot more true than you might think.
And it all traces back to this project, Multics. It's the foundational yet almost completely forgotten ancestor of pretty much every secure operating system we use today. It was this massive, unbelievably ambitious project that pioneered concepts we absolutely take for granted, and yet most people have never heard its name. So what's the deal?
To really understand Multics, we've got to jump in a time machine. We're going back to the 1960s. And let me tell you, computing was a totally different world. See, before Multics, computers worked on something called batch processing. Imagine this, you'd write your program on a stack of punch cards, hand it to an operator, and then you'd wait and wait. Sometimes for hours, sometimes for days, just to find out you had a typo. The goal of Multics was something called time sharing, letting dozens, even hundreds of people interact with one giant computer all at the same time, getting feedback instantly. This wasn't just a step forward, it was a quantum leap. And the ambition here was, well, it was staggering. The vision for Multics wasn't just to build a program, it was to create a computing utility. The idea was that computing power should be something you just plug into, like an outlet for electricity or a faucet for water. Always on, always available, always reliable.
But a dream this big is never an easy road. The project kicked off in '63, but it was just plagued with delays. A key partner, the legendary Bell Labs, actually pulled out in 1969. It took a full decade before it was even released commercially. And get this, the very last Multics system wasn't shut down until the year 2000. Think about that. This project had a lifespan that stretched from the Kennedy era all the way to Y2K.
So with all those struggles, what made Multics so special? Why are we even talking about it today? Well, the answer comes down to one word: security. For Multics, security wasn't something you added on later, it was the absolute bedrock of the design, built on three incredible pillars. Pillar number one is a concept you've probably run into, even if you don't know the name: access control lists, or ACLs. It all boils down to a very simple question: who are you? For every single file, every directory, Multics kept a list of exactly which users were allowed to read it, to change it, or to run it. It's a cornerstone of digital security today. Okay, but this second pillar, this was the real game changer: protection rings. The best way to think about it is like a medieval fortress. In the very center, the most protected part, you have ring 0. That's the king, the all-powerful core of the operating system. Your everyday programs, they live way out in the outer rings. And here's the beautiful part: a program in an outer ring is physically, by the hardware itself, prevented from even touching anything in a more protected inner ring. And the third pillar went full-on military grade. It's called multi-level security. This system asks a different question: what do you need to know? It creates strict, non-negotiable levels of classification. So a program running at an unclassified level is fundamentally blocked from even looking at a top-secret file. It's designed to stop information from leaking downwards, period. And here's the genius of it all. These three systems work together as a single triple-layered checkpoint. Anytime anything tried to access a file, it had to answer three questions. First, the ACL check: are you on the list? Second, the ring check: are you important enough? And third, the MLS check: are you cleared for this level of information? And an operation was only, and I mean only, allowed if it passed all three checks. So it sounds perfect, right? An impenetrable fortress. But if there's one thing the history of technology has taught us, it's that even the most perfect design has to survive contact with messy reality. And Multics was no exception. In 1974, a couple of researchers for the Air Force, Paul Carger and Roger Shell, did a deep dive on Multics. Now, what's so important about their report is that they weren't critics, they were huge fans. As they said, they were firm believers in the Multics approach. Their whole goal was to see where the real-world implementation fell short of the brilliant design. And they found cracks at every level. There were hardware bugs and processor updates that literally let programs sidestep the security checks. There were software bugs where old code written before the security rules were fully fleshed out left gaping holes. And then there were procedural flaws, where a clever attacker could chain together a series of small, seemingly harmless mistakes to take over the whole system. A perfect example was this thing called the master mode flaw. See, to make this system run a little faster, they made a small tweak to how it handled errors. But this little change accidentally gave regular user programs a backdoor to access the most powerful privileged instructions on the entire machine. It's just a classic lesson in security. A small, well-intentioned change can have absolutely catastrophic side effects you never saw coming.
So, let's recap. Multics was complex, it was expensive, and it wasn't perfect. From a commercial standpoint, you'd have to call it a failure. But its story doesn't end there. In fact, this is where it gets really good. Multics became the failure that changed everything.
Let this number sink in for a second. Over its entire life, only about 80 Multics systems were ever sold. By any business metric, that is a flop, a total dud, but its real value was never going to be measured in sales figures. No, its true legacy is in the ideas it unleashed. Ideas that are running on your computer, on your phone, at this very moment. The whole concept of a hierarchical file system, folders inside of folders inside of folders, that was formalized in Multics. Virtual memory, dynamic linking, the core security concept of a reference monitor that checks every single access, all of it came from this one project.
And here it is. Here's the most direct connection to our world today. Two of those researchers from Bell Labs who had worked on Multics, Ken Thompson and Dennis Ritchie, they got frustrated with how big and complicated it was. So they decided to take its best ideas, the clean file system, the way it handled processes, and build a much, much simpler, stripped-down version. And they called their creation Unix, the direct ancestor of Linux, Mac OS, Android, basically the entire modern digital world.
Which leaves us with this one final, fascinating question. The story of Multics is the story of a brilliant design that literally wrote the textbook on how to build a secure operating system. And yet, all these decades later, even with the blueprint in our hands, why is getting it perfectly right? Why is actually building a truly secure system still one of the absolute hardest challenges in all of computer science?